Hello YouTube, and today we are doing the very first video in our data structures and algorithms playlist on linked list. Yes guys, in this video we will be talking about what is linked list, why you should know it, what are its benefits, what kind of questions you can expect in an interview, and how to develop the intuition behind solving a linked list problem in your next tech company interview. But before we proceed any further, be sure to press the like button and subscribe to our channel for getting regular updates on our latest videos. We will be releasing a lot of videos on data structures, so if you guys are interested, make sure to press that subscribe button below. Also, if you're new to our channel, take some time to explore other videos on system design interview. Also, you can visit our website www.techtextula.com to find the text format of these videos on our blog. So without much further ado, let's look at what we are going to cover today. So we'll be looking at basics of linked list. Here we will cover what is linked list, what are its benefits, why it is better than its closest sibling known as array. And then we will look at some of the common patterns that you guys can use to develop the intuition behind solving these problems. And then we will look at some of the famous problems in the end, which interviewers like to ask. For example, how to reverse a linked list, how to merge two sorted linked lists, and then how to find the cycle in a linked list. So please follow along, and in case you have any question during the course of this video, do let us know down in the comment section. It helps YouTube to rank our videos higher and show it to a wider audience. We would highly appreciate it. Thank you so much. So let's start by knowing a little bit about the linked list data structure. So linked list data structure is a collection of nodes that are connected with each other. When it is connected with each other in a single direction list format, we call it a singly linked list. But when it is connected with each other in the opposite direction as well, we call it a doubly linked list. And when all the nodes are connected with each other in no direction at all, we call it a graph. But that is a topic for some other video. So let's see what are the benefits of using a linked list. So first benefit is that it is dynamically allocated. For example, you need to add a new node, let's say 3 in this list. All you need to do is just instantiate this node and then take the 2's reference and put that onto 3 and then put 3's next reference to 4. And all you have is a new list which has 1, 2, 3, 4, 5 as the linked list element. Same goes for removal of the node, where you can simply take the reference of the previous node and point it to the 3's next, and you have deleted 3 node from the linked list. So as you can see, it has quite some benefits from its closest sibling known as arrays in these regards. As you can see that it only takes O1 time complexity to add and remove the linked list node, but it takes O(n) time complexity just like array for element lookup or search. Now let's also see some of the drawbacks of using a linked list. So unlike array, we don't get a random access over linked list elements, as we can't use an index to reach to an element. We have to go through the entire linked list finding that element one by one. Also, it takes extra space to store those pointer references to point to each other. Arrays are much more space efficient in that regard. And lastly, there is no cache locality benefit we can get while using the linked list. Because in case of array, runtime environments often cache X number of previous or next elements for future processing, bringing the runtime even further down in case of array. Now, let's go over some of the common approaches to solve these linked list problems. This will help you guys to build an intuition behind solving these linked list problems in your tech company interview. So most of the problems are easily solved using O(n) space solution, like we will see in some of the recursive approaches. But there are other subtle approaches using iterative solutions that gets us the result in just O(1) space. Also, most of the problems are solved in just single iteration or traversal using one pointer, as we will see in some of the problems in a while. But there are some other problems that takes 2 or even 3 pointers to simultaneously go over the linked list to help us get the solution in the first iteration. A common example could be reversing the linked list, where we need the previous pointer as well as the current pointer and the future node pointer to help us reversing the node at the moment. Don't worry, we will see its solution in much more detail in a while. And the last type of approach would be to use an auxiliary data structure, like a hash table or a stack, to store some of the references or the value. We will see this type of approach while solving how to find the next greater node in the linked list from LeetCode. So let's look at the first type of approach, which is as simple as basic traversal. But before we proceed any further, a small disclaimer that we will only be showing the iterative approach for most of these questions, because we feel that recursive approaches are quite simple and often discouraged by interviewers to use in an interview setting. We as interviewers feel that candidates should know these recursive solutions to most of the linked list problems and the potential downsides of using it but we would only explore iterative solutions to help viewers get a better feel of approaches that matter. So let's look at the first solution of how to reverse a singly linked list. This is a classical problem. So if you are not aware of this, please follow along. But if you are, well, you can move on to the next problem, for which you can find the timestamp link in the description. Let's first understand what the question is expecting us to do. So here we have 5 nodes in the linked list, and we want to end up with a linked list where all the nodes are reversed. A technical definition would be to reverse the pointer references of each node. For example, where earlier 1 was pointing to 2, now 2 will be pointing to 1, and 2 was pointing to 3, and now 3 will be pointing to 2, so on and so forth. Now a brute force solution would be to store all these numbers in a stack and then pop the top element to store at the head of the linked list by creating a new node. But while we are doing so, we are using O(n) extra space to store these nodes and also the stack, which is suboptimal solution. We want to solve this problem in O(n) time complexity and also O(1) space complexity. So what we will do is to reverse the pointer reference in place only. That is, while we are moving along the linked list, we will reverse the pointer references for each node at its place only. And in the end, we will just return the head of the reversed list at the tail of the list. So let's try to understand this through code only. So here we have initialized 3 pointers: previous, current, and r head, which stands for reverse head. Now all we are doing is to move the current dot next to point to the previous node instead of its next to reverse the pointer reference, and move along the linked list one node at a time. This way we will reach till the end of the list and have reversed all the elements and will return the previous pointer in the end, which will be the new head. Now let's look at another problem. This one involves 2 linked lists where we have to merge these 2 sorted linked lists into one, which also should be sorted in the end. As with any data structure question, let's start with 1 or 2 example cases to see if we are not missing any edge cases. So here we have 2 sorted lists with their 2 head references. Now one can ask that if there is any guarantee that there are at least 1 node in either of the list. Well, let's say that it's not guaranteed and we have to handle that scenario in our code. Another question would be that if both the lists are of the same size, let's say that we were not given that and we have to handle that case as well. So if we take the basic case here, all we need to do is just check which head contains the minimum of both the values and then use that as the current head for the resulting sorted linked list. And from there, just check one node at a time from each of the list and add it to the new resulting list tail. This is quite simple in principle. So now also let's take a look at the code. So here we are first taking care of the edge case where we were only given one linked list with non-zero elements. So we will be checking the L1 head is equal to null. Then we will just simply return L2. It doesn't matter if L2 is also null, because if both are null, the resulting list will also be null. And same goes for L2. Now the next step is to find the minimum of both the head elements. Let's say L1 contains the smaller element, then we will set the new resulting list head to L1, and we do the vice versa in the scenario. Now all we need to do is just traverse through each of the list head element and see whichever is smaller, and then put that in the end of the new result list. Once we have hit the end of either of the list like L1 or L2, we just simply have found the null for either of the list. At that time, we will just break out of the loop and then come out to this case, where basically we are assuming that if we have hit the end of the list, where basically we are assuming that there are no more elements available in either of the list, and it could be that the other list would have the remaining number of elements which can be placed at the end of the tail of the resulting list like this. In the end, we will simply return the head reference of the resulting list that we have sorted earlier here in this step. This approach took us O(1) space complexity since we didn't use any extra space, and O(n) worst case time complexity in case we have to traverse through all the nodes from both the linked list. Now let's look at the last question in this video. So in this problem, we want to find if a linked list contains a cycle. We call it a cycle when the linked list doesn't have an end to it, by which we mean that the potential tail node just references back to one of its earlier nodes in the list. So one brute force solution would be to store all the references of the nodes in a hash table, and then as we traverse in the linked list, just check if we have already seen a particular node reference earlier or not. This is simple and also has a linear time complexity, but as we all know, it uses O and extra space to store the references in a hash table. Another approach would be to use the runner technique. By this we mean that we use two pointers, one which is fast moving and one which is slow moving. So the fast moving pointer would hop over two nodes at a time, while the slow one will only move one node at a time. And if in case there is a cycle, they would eventually meet somewhere in the middle. Let's take an example. So here we have 5 node elements in our linked list, and the end element, which is 5 in this case, pointing back to the 2 node. So first, fast pointer will move to 3, and the slow pointer will only move to 2. And then the fast pointer will move to 5, and the slow pointer will only move to 3. Similarly, again the slow pointer will move to 4, and in this case now the fast pointer will be at 3 because it is hopping 2 nodes at a time. And in the end, both slow pointer and the fast pointer will meet at the 5th element of the node, because fast will be hopping 2 nodes and slow will only just travel 1 node at a time. Now, as we have seen that this is very efficient to find the loop or the cycle in the linked list, let's also quickly look at the code for this problem. So here we have initialized both fast and slow pointer at the head of the linked list. Now all we have to do is just check that neither fast or nor fast next reference ever makes it to null, and all we have to do is just move fast twice by doing fast.next.next, and only move slow with just one pointer ahead, which is slow.next. And in case if fast ever meets slow, both will be equal, and we will just exit out of the code by returning the status as true. But if in case fast does reach to null and it just breaks out of this while loop, we only return false in that case, means that there is no cycle in the linked list. So one of the common traps to be aware of is that to focus really on the edge conditions. Like if someone will miss or write it wrong, the fast equals slow, it will be a never-ending loop or infinite loop where we will never reach the end condition or termination condition for this while loop. So always be aware of your termination conditions for while loops. Let's do the complexity analysis of this code. So we only have traveled all the nodes at least one time. So the maximum complexity will be O twice of n or thrice of n, so that like we have at least traversed 2 times or 3 times the same node, but that will still come back to n. And the space complexity is only O1 because we are not using any extra space. We just used 2 extra pointers which are nothing. So there we have the top 3 problems that interviewers would like to ask in an interview situation on linked list data structure. So in this video, we went over the basics of linked list, where we looked at the advantages of using a linked list and also the drawbacks of using the linked list and some of the complexity analysis. We then looked at some of the common approaches like single traversal, single pointer, multiple pointers, single traversal, and how to use auxiliary data structures. In the end, we covered 3 famous interview problems like reversing the linked list, merging 2 sorted linked list into one, and the third one was finding the cycle in a linked list. So I hope you guys have learned the basic concepts plus the tips and tricks on linked list. We want to keep the nature of this video as introductory and as basic as possible. We will be covering more advanced problems in our coming videos, so please stay tuned for that. We'll also be releasing much more videos to solve top LeetCode questions that appear in tech company interviews. So hit that subscribe button to get the regular updates and drop us a like to show us the appreciation. Also, do let us know in the comment section if you want us to solve any problem that you are finding it difficult, or you would need some sort of refresher or second eye to look at it. You can also visit our website www.techtakshila.com to find the written format of this video if you like to prepare for an interview in that way. Until next time, thanks for watching and keep lead coding.